new kind of problem along the same lines, but a new kind. We are going to start with a problem just to get us warmed up, like we've already done. Problem 7. We have already practiced this time. Don't forget Camp Food Drive tomorrow and Wednesday, last day. So if you're going on retreat, you need to get it in tomorrow. Take a look at it and tell me what you think. We can do synthetic division, absolutely we could. Does anybody notice anything about this one though? It can be factored by grouping. Now again, if you want to do synthetic division, the PRRs would be factors of 12 or factors of 1. If you want to do that, that will absolutely work. But this one does factor by grouping, so you can do that too. Either one, doesn't matter. I'm going to go ahead and factor by grouping because we need practice factoring, some of us do. So I'll take an x squared out of the first 2. What am I going to take out of the second 2? Negative 4. And remember, if you take out the negative, these are going to become positive then. So that's why it's x plus 3. There is your match. And then the other parts are x squared minus 4. Right? And then what do we know about x squared minus 4? X plus 2, x minus 2, the difference of squares. Now we're going to draw our number line. There's going to be 3 dots on the number line. They will be open dots, right? And where will those dots be?
-3, -2, +2.
Is that okay? Now what?
Now we just plug in a number.
I plug in a number. I just pick a number, any number that isn't a dot. So Wyatt, what number would you like?
4.
4. Now 4 is out here, so we're plugging in a number out here. We're plugging in 4. 4 plus 3 is 7. 4 plus 2 is 6. And 4 minus 2 is 2. Now that's a big number. Don't worry about multiplying it out. What do we want to know about it? Is it greater than 0? And if you times 7 times 6 times 2, is it going to be greater than 0? Yes. So that means we shade. We got a winner. We're going to shade right there. Now, do we have any funky factors here? Anything squared or anything like that? So I can use my shortcut if I want. If that one's shaded, then this one isn't. This one is, and this one isn't. Now, if you don't like that or you're confused by that, then you can pick a number here and do the same thing you did with 4. Pick a number here, pick a number here to determine if you shade.
When you pick a number, do you just plug into the 3 factors
Right there. Or you could plug it in the original, but that's going to be more arithmetic. All right, so what's my answer? My answer is my 2 shaded sections. So parentheses, -3, -2. Why am I using parentheses? Because the brackets would be closed dots. Or everything from 2 to infinity. Okay, everyone? Now, if you look at the next problem, number 8, it looks different. This, bless you, this is not a polynomial. This is a rational inequality. But here's the good news. You do it exactly the same way. there are gonna be 2 dots on this number line. Where do you think those dots are going to be? -1 and +3. Now we're gonna pick a number. So what number do we want this time? 2? We can pick 2. 2's right here. We can pick 2. 2 plus 1 is 3. 2 minus 3 is -1. Is that less than 0? Yep. So we shade right there where that 2 was. And the same shortcut applies. Neither of these are squared, right? I mean, if we had something like this, it would be different, but we don't. We just have plain factors. So I can use my shortcut. So I figured out I shaded here, so what about these? They won't be. So my answer is just -1 to 3. Isn't that easy? It's exactly the same. Okay, look at number 9. Now it's going to be a bigger problem, but it is not going to be hard. What is the first thing you're going to do?
Difference of squares.
What?
Difference of squares.
You're gonna factor it, the difference of squares, yep. So I'm gonna factor. So I'm gonna have, x plus 3, x minus 3. X plus 2, x minus 2. Would everybody agree with that? How many dots are gonna go on the number line this time? 4. And where are those dots going to be? -3 and +3, and -2 and +2. And I have to be careful that I get those in the right order. That's a number line.
You still have to pick what number was getting multiplied.
Nope, I only need to pick one. But there's something I gotta talk about first. When you see that symbol, what are you programmed to do?
Close.
Shade in the dots, close in the dots. With a problem like this, I'm gonna close in these. But I can never close in denominator dots. Denominator dots have to stay open. Because remember all that domain conversation we had? X cannot be 2, right? Because it's in the denominator. X cannot be 2. X cannot be -2. So if the dot is coming out of the denominator, no matter what the symbol is in the problem, the dot is going to be open if it's coming in the denominator. All right, everybody, that's a kind of a tricky little thing you have to remember. Okay, now I'm gonna pick a point, any point anywhere. It's not those.
1.
1. 1 is in here. Would everybody agree with that? 1 is in there? So I'm gonna put 1 into all my parentheses. So on top, I'm gonna have 4 times -2 and 3 times -1. I'm putting 1, 1, 1, 1. Now I wanna know if this answer that I get is bigger than 0.
Yes.
What's -8 over -3? Isn't that 8/3?
Yeah.
Is 8/3 bigger than 0? So what does that mean? I'm gonna shade. Now, none of these are squared. There's nothing weird about this problem. The factors are all normal. So if I shaded this section, then I
Don't say that.
won't, but I will. I shaded this one, so I won't shade this one. but I will shade this one. Every other one. So now my answer,
Right.
not on the infinity. The infinity, remember, is always parentheses, but the -3 is gonna be bracketed. Or -2 to 2 in parentheses, because those are open. Or 3 to infinity. Okay. Easy enough? Oh no. Now they're getting a little tougher. Tell me what looks different about this one. Josh?
The number, there's actually a number on the right, it's not just a 0.
Yeah, and I need it to be a 0. I need that number to be a 0. Okay? So, any suggestions on,
Could you multiply 4 almost?
Subtract.
well, that wouldn't help, but subtracting
subtract.
4 would work. Yes, so we're gonna subtract the 4 over. So I'm gonna -4 on both sides. Now, I went ahead and wrote this as 4 over 1. Okay? So I move that 4. I must have 0. So all my problems up to this point have had 0, it's been perfect. This one doesn't, so I need to move the 4 over so I have a 0. That's step 1. Now, I would love for this problem to look like this one. So what I'm going to do is get a common denominator. My denominator of my fraction is going to be x minus 3. This one needs an x minus 3, so I'm going to give it an x minus 3. So what will my numerator look like now that I put an x minus 3 up here with the 4? X plus 2
minus 4x
minus 4x
minus 12.
plus 12. I wish I
Oh,
had a
because it's
nickel
negative.
for every time that mistake is made. Oh, kids do it, people do it all the time. This is a -4, and we're timesing it by a -3, so that becomes a plus 12. Okay, so the first thing I had to do was move that 4 over to the other side. Okay? Then I've got to subtract these. I got to make one fraction, so I made my denominators match. Now, can I do anything with my numerator?
Well, I like that.
So -3x plus 14 Now there is 1x, I have my 0, which is what I wanted. There's 1x on the top and 1x on the bottom. So I'm going to have 2 dots on my number line. And I bet everybody can tell me where that dot is. That dot's a 3. This one is a little bit harder to tell where it is. So all you have to do is over to the side, solve that. Solve your numerator. This is going to tell me where I'm going to put my dot. So where's my dot going to go? At 14 thirds. Which, if that confuses you, write it as a mixed number. That would be 4 2/3. So on my number line, I have a dot at 3 and a dot at 14/3 or 4 2/3.
That dot close.
Yeah. Should I close in both
Not the-
dots,
not
one
the
dot,
three.
which dot? What am I doing here with my dots?
14/3.
No, they're not gonna both be closed in, because what's our rule about denominator dots? Denominator dots are always open, always. If it's in the denominator, it's open. So, the 3 is gonna be open, but the 14/3 will be closed because of the symbol. Right? Alright, let's pick a number. 2, 2's over here. What happens if you put 2 in your numerator? What do you get if you put 2 right there? -6 plus 14, which is 8. And what do you get if you put 2 in the bottom? -1. Is -8/1 less than 0?
Yes.
Okay, so we shade it. And if we shade that one, we don't shade this one, and we do shade this one. So -infinity to 3, and then bracket 14/3 to infinity. Those problems aren't hard, but there's a lot to keep track of, a lot to remember to do. Alright, did I lose anybody in there anywhere? Anybody have a question about one of those steps? So we're gonna do another one, just like it. Okay, next problem. Okay, here we go. Step 1, who's got a plan? Subtract the 2. And you don't have to do this, but when I bring it over, I usually put it over 1 so I can see it has a denominator. Move that 2 over. This is 2 over 1. Move the 2 over. Perfect. Now what?
Common denominator.
Get a common denominator, and my common denominator will just be x minus 1, right? So that's good, so this one's gonna get an x minus 1. And now I can put them together. I have to keep the denominator because it's an inequality. I can lose denominators in equations, but not in inequalities. So I make one big giant fraction. And what will the top be? 3x plus 1 minus 2x, not plus 1, plus 2, because you're timesing, right? Alright, so what's my numerator?
The X. And that's the number.
It's gonna be just plain x plus 3, isn't it?
Yeah. That's why.
So here's my number line. Here are my 2 dots. Where are my 2 dots going to go? -3 and 1. This is an easy one to tell, right? -3 and 1. Pick a number.
2.
2. 2 is here. So if I put 2 in, I get 5 over 1. Is that greater than 0?
Yep.
So I shade out there where 2 is. And if I shade it there, then I don't shade there and I do shade here. So what are you putting in the answer blank?
Should negative 2 be, or, wait. Never mind, I mixed.
So parentheses including.
If your symbol is
Why?
this,
That's not what I got.
Mackenzie,
We're on the same problem.
there's no colored in dots in this problem.
Oh, there's no line underneath.
Yeah.
Yeah.
So parentheses, parentheses, negative infinity, -3,
I don't know what I did.
union, 1, infinity. Is everybody okay with that? Okay, and here's what I need you to do now. We're gonna just pause for a moment, we have some word problems to do. But first I wanna do a quick little review, because we're gonna have a quizzy poo.
Right now?
Get out a sheet of paper. Get out a sheet of paper.
You're really funny. I know. This is a really big piece of paper.
And I can't.
We're gonna practice 3 problems right now. Okay? Put those away before I rip them out. Put them away. This is math class. We don't need that stuff. All right. So here we go. So, take a breath. Switching gears. This is an equation. What do I do? What is my process in an equation, an equals problem like this? What do I do?
Factor.
Factor anything that'll factor. So it looks like this denominator will factor. And how does it factor? X plus 4, x minus 1. All right. Now what? Well, now wait, I can't cancel anything until I make all the denominators the same, right? Don't just start crossing off denominators, they all have to match. So this one needs an x minus 1. This one needs an x plus 4. And that one doesn't need anything because it already matches. Now at this point, in an equals problem, only in an equals problem, what am I allowed to do? Get rid of the denominators. Poof, they're gone. So all I have is 3x minus 1 minus 2x plus 4 equals 3x plus 5. Now again, don't do that in an inequality. If this was a less than, you could not do that. That does not work in an inequality. It's one of the magical things about an equation, equals. Okay, now what?
Distribute the.
So 3x minus 3, watch your signs. minus 2x minus 8 equals 3x plus 5. So collecting like terms now?
Yeah,
Looks like, what do we have over here?
x minus 11
X minus 11,
equals 3x plus 5.
okay?
And you gotta get that x minus.
So, doesn't really matter which way I go, I can subtract x from both sides. So negative 11 equals 2x plus 5. And then I can
Subtract 5.
subtract 5. So negative 16 equals 2x, and it looks like x equals negative 8. You okay with that, everybody? Okay. All right, so there's one practice problem. Any question about that? Understood all the steps. Started by factoring, got a common denominator, made all the denominators match, then we could get rid of the denominators, and then just solve what we had left. Okay? All right, next problem. All right, take a look at this guy. What do you think you're gonna do with him? What do I keep saying? If you can factor it, factor it. So, does this thing factor? How? Plus 2 plus 3? Now, this one has an inequality in it, which automatically means I'm going to be using a number line. I didn't use a number line in my last problem because it was a plain equals. On the number line, we'll go 2 dots. Where will those dots be? Negative 2 and negative 3. Watch your order. Remember, zero's out here somewhere, right? Number line. Tell me about those dots. Closed. Now earlier I was talking about sometimes they're closed, sometimes they're open, but that's only if I have a denominator. The denominator is what causes the problem. So these are both going to be closed in. And then what do I do?
Check a random one.
Check a random number anywhere. So what random number?
1.
1. 1 would be out here. So I'm checking 1. So 1 plus 2 is 3. 1 plus 3 is 4. Those are being multiplied. Is 3 times 4 bigger than 0? So I shade out here. I don't shade here, and I do shade here. So my answer that goes in the answer blank is not the number line. The answer that goes in the answer blank is negative infinity, negative 3, parentheses, bracket, or union to infinity. which means at some point I'm going through the number line. But what do I need to do first? Factor. How does the top factor?
X plus 6.
Minus 2.
6 minus 2. What's 6 times negative 2? Negative 12. What's 6 plus negative 2? 4. Okay. Now I'm ready to go to the number line, and there will be 3 dots on the number line, right? Because there's 3 X's in there. So where will the dots be?
Negative 7.
Negative 7,
Negative 6.
negative 6,
Positive 2.
and positive 2. Everybody okay with that?
Negative 7 would be open.
Exactly, Josh,
because
very
it's in the
good.
denominator.
I see this symbol right here, and I want to color in my dots, but denominator dots are always open. Because X can't be 7. That's a domain thing. X can't be, or negative 7, I mean. So even though it's an or equal to, if it's a dot coming out of the denominator, it's gonna be open. Okay, now what? Pick a number. What number do you want? 3. 3's out here. You can pick whatever number you want, as long as it's not B. So if we pick 3, 3 plus 6 is 9. 3 minus 2 is 1. And 3 plus 7 is 10. Now don't worry about the actual number, you can if you want. All you want to know is it bigger than 0? Is that combination right there going to be bigger than 0? Yeah, because they're all positive. So that means, I think every number you pick today has been a winner.
Let's go.
That it's shaded. Then this one doesn't. This one does. And that one doesn't. So then I can write my answer. Negative 7, negative 6. We'll have an open, a parentheses on the negative 7, a bracket on the 6, or 2 to infinity. Okay? Alright, so now what we're going to do is I'm going to put 3 more on the board. And I want 3 people, 3 like that we just did. I want 3 people to come up and okay. All right, so I can get 2 of them on this board. So if you're over here, you're gonna be on video. And then we'll get the other one over.
I believe.
I really cannot.
I might actually know.
No, I was watching this one very late,
And you can hear like the
Josh, you doing this or what?
That's really good.
watching ones like where we're in together is so funny because you can like hear what we're saying. It's the best thing ever.
Oh yeah. Oh
Yeah, I'll
yeah.
do it. I'll do it.
And oh yeah.
I'll do it.
No, but this is from sophomore. This was the day
I worked
when I got picked up from school. I locked my keys
Yeah, I
in
need one more
my
volunteer to do this one over
in
here.
the house, and I left my phone and my backpack all in there.
I'm looking
So I went to school without a phone or a backpack because Addison took me, but I didn't have any way to get in the house. So it's like, and I couldn't call, so I was like, I'll just go to school without a phone or a backpack.
Okay, and you guys should be doing these problems instead of chatting. Cause guess what happens tomorrow? You all get to do this on your own.
No, she said we have to.
Oh, sorry, I'm looking away right now.
You better check that factor and,
Did I do it wrong?
well, check it.
No, it's close.
Tegan, don't worry about your answer being weird. I just totally made this problem up, so it could be completely crazy.
Wait, bro, I'm choking.
Right answer.
I'm like choking under pressure. Why can't I get this?
Okay, be
Nine
quiet.
and one. It's gonna be
Oh,
the best
nine.
experience of your life.
What, retreat?
But it's
Alright, give me numbers.
It's so good. It'll be so good.
No.
plus.
You'll love
At
it.
first, like, it's low key weird.
There we go.
So I'm gonna take
And now-
3. I'm playing 3.
Alone with your thoughts. And your thinking. And by the end of
Stop.
it, it's
Stop.
really
Stop.
I'm stuck, what do I do now?
He's got it
Oh, I'm already at the
factored.
number?
They're all kind of ended for me, and when it ended, I was like,
Oh, the line.
sucks.
Negative 9.
Plot one and
For the
negative
high
one.
size.
Oh, you just fixed the number?
Tell them I just thought back to it.
So, one, what's that?
Give me a new number.
Two.
What number did you try?
3.
And what's wrong? What do you need to
Alright,
do?
somebody give me a number, y'all.
2.
So the
So you
zero.
got 11 over 28, okay. Is that less than 0?
2 minus 1,
No, so it worked.
2
So
plus
shake it.
9,
Wherever 3 is,
9 over
shake it.
10.
11.
3
It's 9
works.
over 10.
So 11, guys.
not
Is 11 less
No, but
than
I'm just
0?
what sign is this?
Is 11 less than 0?
More?
No, it's not.
Okay.
So,
Here. So our answer is
it's not. So you
No. So
say.
then, that means that.
Wait, if it's not, where do I not shade it all? 'Cause we
You
don't-
don't shade that section.
We don't shade the section, but if we don't shade this one, we shade these,
Yes.
and if we don't,
Did I do that right?
You use the or?
That was a lot harder than I thought. Why did I have to go all over here?
we're gonna hit them with,
Or is it,
ooh.
or is it, it's always in for these two?
No, it's easy.
Or, oh, okay, but we don't use the,
Good catch, Josh, good catch.
And then we'll hit them with the boom, boom,
I know.
boom. Another bracket.
That was like a silent, like,
One.
you guys.
Okay, now wait a second, Tilly. You put in 3, right?
I tried to get 3.
The number you get doesn't matter. The number you got was positive. Okay, is positive anything less than 0?
No.
No. So you put in 3 and it didn't work.
That's right.
So you don't shade it.
So you need another number.
You don't need to pick another number. If you don't shade this one, then you do shade this one, you don't, and you do. So your answer should actually be backwards of what you had. Because the number you picked 3, which is fine choice, but it gave you a positive number. You wanna be less than 0. That is not less than 0. So therefore, it doesn't get shaded. And then you can alternate. You don't shade that one, then you do, and you don't, and you do. Okay? Alright, so how did Josh do over here? Got it factored, put his dots up there. What number did you test, 2?
Yeah.
2 gave him 1 times 11. That is not negative, so see, he picked a loser also, didn't shade it. So that meant the ends were shaded. And then Tegan over here, she kind of shortcut it a little bit. I want everybody to start by factoring. And then making your denominators match. And then you can drop them out. So she said 2x minus 10 minus 4x equals 9x plus 27. And then she went ahead and solved and got that. No number line for question number 1. We only use number lines when the problems have these in them, right? All Tilly's dots were open because the symbol in the problem was just less than. If hers had been an or equal to, nothing would change about my answer except this dot would be colored in, only that one.
I'll be super
Okay, all right, so that's tomorrow. Now let's get back to our notes and we're gonna do some word problems, some of which we have done already and some of which we have not. All right. Word problems, number 1. How much 12% orange juice needs to be added to 5 gallons of 15% orange juice to get a 14% solution? Have we done this before?
Yeah.
What's our strategy?
So,
Amount times percent plus amount times percent equals amount times percent. What are my percents in the problem? I should have all of them. I have 12%, 0.12. I have 15%, 0.15. And I have 14%, 0.14. How much? X? Guys, don't look at me blankly, we've done this before. Should be added to 5 gallons of 15%.
So 5.
This one's gonna be 5 plus X, because aren't I adding these two together to get the total? Then I use my calculator to help me with any arithmetic here. 0.12X plus 0.75 equals 0.70 plus 0.14X.
where did you get
0.70, this is a distributed. What's 0.14 times 5? So if I subtract and I warned you before, and some of you still were making this mistake. What happens when you subtract 0.14 minus 0.12? It's 0.02, not 0.2. It's 0.02. I think it's 2.5 gallons. kids, review, review, review.
Oh, so basically, it's like, I'm not doing anything here.
All right, let's see if you can set this one up. All right, here we go. What are my percentages?
0.54,
154.
0.8,
And I end up with 0.60. Wait a second. 8 cups. Where does that 8 go? That goes right here. That's a little unusual, but that's where it goes, right? And it's mixed with some 84, a 60 results. How much? 84?
X.
So that's X that goes with the 84. Does that make sense to everybody? And these are getting added, so what's gonna go here? 8 plus X? They're being added together? So 4.32 plus 0.84X equals, this is always a distribute here, or this is a distribute, so make sure you're doing that carefully. I'm gonna subtract those over to here. Subtract that over to there. Cups, I got 2 cups, but I did some of that in my head, so it could be totally wrong. All right, everybody okay with that? Now, we got a couple of problems here. 3 and 4 are a new kind of problem. Actually, they're not new to you. You did them when you were freshmen in Algebra 1. You probably forgot them, maybe not. Danielle can do her math homework in 4 hours. If Zach helps her, it takes him 3 hours. How long does it take Zach alone? These are called work problems. Got people doing a job together, alone, whatever. And the strategy, the easiest way to approach these problems is to just follow a little formula, kind of like this is a little formula. 1 over alone plus 1 over alone equals 1 over together. So these problems involve 2 or more people doing a job. So each one of them can do the job in a certain amount of time alone. And then they can do the job in a certain amount of time together. So for this problem, number 3, Danielle's time alone is 4 hours. If Zach helps her, it will take them 3 hours. What's the 3? That's their time together. The question is, how long does it take Zach alone? So I'll call that X. Does that make sense? It's always 1 over alone plus alone together. Can I make all those denominators match? What would they all have to be if they were all gonna match? 12x. So this one needs a 3x. I'm making them all 12x. This one needs a 12. this one needs a 4x. Now, this is an equals problem, so if you want, what are you allowed to do in an equals problem? Once the denominators match, you can get rid of them. So 3x plus 12 equals 4x. So x equals 12 hours. It takes Zach 12 hours to do the job alone. Okay, that's pretty easy. All right, one more of those. Grant can paint the football field in 8 hours. Matt can do it in 6. How long does it take them to do it together? So 1 over alone plus 1 over alone equals 1 over together. That's our format. So here we go. What do I do with the 8? That's him alone, right? So 1 over 8. What do I do with the 6? 1 over 6. That's his alone. And then I don't know what their time together is.
So it would be 48x would be
So,
the denominator.
A common denominator, there are other common denominators, but a common denominator would be 48x. So this one has to be times by 6x. This one by 8x. And this one by 48. All the denominators match. It's an equals. So 6x plus 8x equals 48. Does that sound right? So 14x equals 48. And x equals 48/14. Which you can either reduce to 24 over 7, or you can get a decimal for that, and say about 3.4 hours. Now, no word problems on the quiz. What kind of problems on our quiz? The ones that we practiced, right?